Hello everybody, Mr. Hissner here, and today we're going to continue on triangles, and we're just going to jump right into the algebraic properties. So let us take a look at some triangles and use some algebra to get to the bottom of some of these problems. So first we have a couple different means. So what we're going to do is look at just the sides of the triangle. And so this one says that triangle ABC is an equilateral triangle, equilateral triangle. So that means that all of these sides are the same. And we want to solve for both x and y. And so what that would look like is, well, if these three things are all equal, that means that, let's say, for example, we would know that BC, the measure of BC would be equal to the measure of BA. Right? And so BC is 3x plus 1, and BA is 49. We would also know that AC is equal to BA, and AC is 18y minus 41, and that is equal to 49 as well. And so what you can see here is that we're just using the fact that the property that this is an equilateral triangle, which means that we have four equal sides, right? Or three equal sides. And so what we can do is just set up a simple algebra problem for both to find both of these. So here we go. We got 3x is equal to 48. We find x is equal to 16. And similar with y, just add 41 to both sides. Is equal to 90. So y is equal to 5. And that's what we're doing here. So yeah, this one is different as it's asking you to find the measure of each side. So for here, we need to find x, right? X is equal to something, and then st is equal to rs is equal to rt, because these are, again, it's an equilateral triangle. So once you find one side, you find them all. So just take this and plug it into one of these, and you're good as gold. What's different here? Well, here in this example 4, we're told that this is an isosceles triangle. So we're told that DE and EF are congruent. So what we can do here is set up an equation, solve for these, and then use that value to find the remaining sides. So let's do that now. It says find the measure of x and each side. So first let's find the measure of x. Well, these two things are the same, they're congruent, and so they are equal. So we know that 8x minus 13 is equal to 5x plus 17. And I'm just going to subtract the 5x from both sides. So these two cancel, and then I'm going to add my 13 to both sides. So these two cancel, and then I have a balanced equation, right? So we have 3x is equal to 30, divide both sides by 3, and we find x is equal to 10. And then off to the side, what I'm going to do is I'm going to write some things. So I'm going to write ED is equal to, EF is equal to, and then finally DF is equal to. And I'm going to use my value x to find those measures. So we have ED is 8 times x minus 13. So that's 8 times 10. 8 times 10 is 80 minus 13, so that's 67, right? And hey, EF and ED, these are the same measure, so this one's also going to be 67. Don't have to do any math for that. And then finally, our last value is going to be x plus 21. So 10 plus 21, so that is 31. And then I'm just going to move this over. And that way I have all my answers right here. So these are my answers. I'm going to put a little box there. So what did we do? Well, we just used algebra very simply. We took the idea, the definition, equilateral, right? Equilateral, all sides are equal. So we just made an equation. And then also isosceles. Just remember that isosceles is the same way where we just need to use that property. It means these two sides are the same, so we're going to set up an equation. And really, there's nothing to it. So thanks for watching, guys.